Welcome to Scholars Edge tutorial. In this video, we'll be looking at a topic called dimensional analysis. Recall in our last video, we talked about dimensioning, where I showed you how to dimension different physical quantities like force, acceleration, velocity. So in this video, we'll be looking at dimensional analysis. Now, what is dimensional analysis? Dimensional analysis is a method or technique of showing the relationship between physical quantities. The method or technique of showing the relationship between physical quantities is what we refer to as dimensional analysis. So let's take our first question. Question 1. The question says, the pressure of a flowing fluid depends upon the density rho of the fluid, the acceleration due to gravity g, and the height with which the fluid flows. What is the relationship between these parameters? If you did not get the question, I will repeat. The pressure of a flowing fluid depends upon the density rho. That the symbol for density is rho of the fluid, the acceleration due to gravity g, and the height with which the fluid flows. What is the relationship between these parameters? Recall, I said dimensional analysis is a method or technique of showing the relationship between physical quantities. So let's see how we can solve this problem. And you can see from the question, they said, what is the relationship between these parameters? Let's see how we can solve this question. So first, I will divide my screen into two. The reason I divided so that all our solvings can actually enter this page. So if you read that question again, they say the pressure of a flowing fluid depends upon the density of the fluid, the acceleration due to gravity, and the height. That means for you to get the pressure, we need density, we need acceleration due to gravity, and we need the height. And how can we write this? Okay, first of all, if you are given this kind of question, the first thing is to write out your given parameters. Write out your given parameters and their dimension. You're given parameters and the dimension. So we are given pressure, and recall that pressure, the dimension for pressure is m per l per t square. If you don't know how we got this, please watch our last video. I'll drop a link for the last video on dimensioning. Watch that and you will learn how to dimension all of these quantities. And for acceleration due to gravity, we have L per t square. We have for density which is rho. This symbol here is called rho. That is symbol for density. And we have m per L cube. And for height, we have L. So this is the dimension for all of these quantities. Now, the next thing is, how does these quantities, how do they relate? How do they relate? Recall the question says, the pressure of a flowing fluid depends upon the density of the fluid, the acceleration due to gravity, and the height with which the fluid flow. What is the relationship between these parameters? So we are asked for the relationship between these parameters, but we need to also know how do they relate. First of all, what is their relationship? Now, when they say the pressure of a flowing fluid depend upon, that depend upon can also be written as is proportional to. It also means proportional to. I recall the sign of proportionality. So we say the pressure of a flowing fluid, that's to say we have the pressure is proportional to density acceleration due to gravity, and the height. So we have something like this. So we actually have something like this. P, which is pressure, is proportional to density, acceleration due to gravity, and the height. So our primary assignment in this question is to find out the correct way, or their correct relationship. This is their relationship, of course, but the correct way to write this relationship. That is what we are actually asked to do. That's what we refer to as dimensional analysis. We are asked to find the correct way we can write this relationship. Now, when we say something is proportional, writing this, we introduce a constant called K. So we have P equals K rho GH. Next thing is, we also introduce powers. Power for density, power for acceleration to gravity, and power for height. These powers, we call them S, Y, Z. So introducing S, Y, Z powers, which we now have P is equals to K rho to the power of X, G to the power of Y, and H to the power of Z. Yeah, that is what we are meant to do. Now, after this, what's our next start? Our next start is to introduce or to substitute the dimensions for this quantity. So instead of writing P equals, we will now write the dimension for P equals K, dimension for density, dimension for gravity, dimension for height. So substituting the dimensions. Now we also recall something. For this one, we call it equation 1. This P equals K rho to the power of X, G to the power of Y. So we call it equation 1. Now substituting dimensions, we have this M per L per T square equals K into, this is for rho, recall for our rho, this is what we have, to the power of X. This is for acceleration due to gravity, recall, this is what we have, to the power of Y. Remember, we said we will introduce these powers. Then this is for height, to the power of Z. So substitute the dimensions into the equation. Recall, we call this equation 1. So after putting this as your equation 1, you substitute the dimensions into the equation. Now, next thing is to expand the bracket. So to expand the brackets, look at this. We are expanding these brackets on the right hand side because there is no bracket on the left hand side. To expand the bracket, first we write down this, which is for P equals K. K is just a constant. Recall, this K is a constant, or we call it a dimensionless constant here. Sometimes they might give you a question and give you the value for K. They can say K is actually 1, maybe K means 1, or K is just, and if they don't give you K, it's just know that this K is a dimensionless constant. It's always dimensionless constant. They can say the value for K is 3.2. So you just substitute 3.2 as the value of K. So to open this bracket, recall whenever you have a power, you have something like this with a power side. This power here is multiplying everything inside this bracket. So M to the power of X, which is how we got this dot. This dot here means, all these dots you are seeing here means multiplication. So instead of writing times, you can write dots. So M to the power of X, which is you have M to the power of X. L raised to the power of negative 3 times X. This negative 3 times X will give you negative 3S. So L to the power of negative 3S. This is how we got this. Then dot L to the power of Y, which is how we got this. And negative 2y, negative 2 times y will give you negative 2y. So T to the power of negative 2y, which is how we got this. And L to the power of Z. This is how we got this. Now, next thing is we'll pick one base for each of the terms. You can see we have M here, we have L, we have T, we have L. Recall in the last video I told you guys about indices, where if you have if you have two terms or two bases that are same, you have to what? Pick one. So we're picking out one of this L and we'll add the powers. This is multiplication, we'll add the powers. So we have this m per L per t square equals k dot mx, m to the power of x. You can see m is only one, so we pick out one of the L, which is this, and we add the powers. The powers is what? Negative 3x plus y plus z. Then for the last term t, we are actually doing this in form of MLT. What's the last bit on dimension? I told you guys that dimension is based on MLT, so you don't have to rearrange it to be LMT or LOTM. Even if m is here and maybe t is here, always make sure that m comes first before L and t. So that's why we have this. Now the next thing is to compare the powers of MLT on both sides. Compare the powers, or should I say equate the powers. Check for the power of m here, for the power of m here, and equate it. For the power of L here, for the power of L here, equate it. For the power of t here, and for the power of t here, equate it. Yeah. That is the next thing you are meant to do. Check for the powers and equate them, or you can say compare the powers of MLT on both sides. So for m here, m has the power of 1 here, and for the power of s here, so for m we have 1 equals s, and so we are equating the powers. Then for L, here it has power of negative 1, and for L it has power of negative 3x plus y plus z. So we have negative 1 equals negative 3x plus y plus z. And for t here, power is negative 2, and here is negative 2y. So we have negative 2 equals negative 2y. So we call this equation 2, we call this equation 3, and we call this equation 4. Recall we already have our equation 1. This is our equation 1. So we call this equation 2, equation 3, and equation 4. Next thing is look at these equations we have here. 1 equals s, negative 1 equals negative 3s plus y plus z, negative 2 equals negative 2y. Which of these terms will be easier to solve? We already know that x is equals 1, so we found this already. Now look at y, look at z. Between these two now, which of them will be easier? Which of them can we find first? Will it be easy to solve for z here, or it will be easy to solve for y? So we'll actually use this equation 4 to solve for y, because it's very easy to solve for y here than solving for y here. So let's solve for the values of s, y, and z. So solving for the values of s, y, and z, from our equation 2 here, we know that x is equals to 1. From our equation 4 here, we know that negative 2 equals negative 2y. So what you have to do to get y is to divide both sides by negative 2, and we have y is equals to 1. And from our equation 3, we know that negative 1 equals negative 3s plus y plus z. So what you have to do is to substitute the values of x and y. So we already know that x is equals to 1 and y is equals to 1. If we substitute these values, we have that negative 1 equals negative 3 brackets x was supposed to be here, so we replace it as 1, plus what's supposed to be here, y, we replace it as also 1, plus z. So expanding these brackets, we know that negative 1 equals negative 3 times 1 give us negative 3, so negative 3 plus 1 plus z, and we have negative 1 equals negative 3 plus 1 give us what? Negative 2, so negative 2 plus z, which will give us, if we take this negative 2 to the right hand to left hand side, because we want to make z show up to the formula, we'll be having negative 1 plus 2 equals z. Therefore we have our z equals 1. So you can see that s is 1, y is 1, z is 1. So we have found the values of x, y, and z. Now the next thing is, since we now know the values of x, y, and z, next thing is to recall this. Recall this our equation 1, where we had p equals k rho to the power of x, g to the power of y, and h to the power of z. So what we have to do now is to substitute the values of x, y, and z into this our equation 1. So we have that p equals k rho to the power of 1. Recall rho was raised to the power of x. So what is the value of x? We have x as 1. So rho to the power of 1. G to the power of y. Now we had y as 1. So g to the power of 1. And h to the power of what? Z. We had z as 1. So h to the power of 1. Now anything raised to the power of 1 is that same thing. So that's why we have p equals k rho gh. Now you can decide to stop here. If you stop here, this is your final answer. You are very correct. Now you can decide to also go further and state that assuming k equals 1, that is if you are not given the value of k, you can write maybe assuming k equals 1. So you can also extend to this side. Here you have p equals rho gh. Now you can also decide to stop here, whichever way or whichever way you decide. If you decide to stop here, if you decide to stop here, you are very correct. Depends on k. If you are given the value of k, maybe you are given the value of k as 2, so you write 2 rho gh. Yeah. So if you are not given the value of k, you can assume that k is equals to 1. So whichever way, I can decide to stop here, I can decide to stop here. Wherever I stop, you are very correct. So this is how to solve questions on dimensional analysis. So let's solve one more question before actually ending this video. Question says the velocity v of a wave set up in a stretch string depends on the tension F in the spring, the length L of the spring, and mass M of the string. Use dimensional analysis to find the exact relationship. So you can see in this question we are also given velocity. We are given the velocity of a wave set up in a stretch string depends on the tension. So they've already told you the relationship. They've told you the solution of the formula. Anyone that is depending upon the other is the solution of the formula. So we can say V is proportional to F, L, and M, because we are given tension as F. We are also given length as L, and we are given mass as M. So you can say V is proportional to F, L, and M. Now it also means that the first quantity given is the one always dependent. They might actually give velocity as maybe as the last quantity. They might just rephrase the question and give velocity as the last quantity. Just know that anyone depending on the rest, or they can actually say the tension F in of a spring, the length L of a spring, and the mass M of a spring is being dependent on by the velocity of a wave. So you know that the one doing the one depending on is the solution of the formula. So this one now we have the velocity of a wave set up in a stretch spring depends on. So you can see that velocity is the one depending. Yeah. Anyone depending is the solution of the formula. So just note that. So let's start with our given parameters. Always ensure you write out the given parameters, and their dimension. So from the question we are given velocity, and we have velocity as L per T. We are given tension. Tension is force in a stretch spring. Yeah, force in a spring. In a stretch spring, that's what we call tension. So we use dimension for force, which is mL per T square. Then we have for length, which is L, and for mass, which is M. Next thing is to write the relationship. Write the relationship of these given quantities. Recall, V is dependent, velocity is dependent on all of these. So velocity is proportional to all of these. So we have this, and removing this proportional sign, we have V equals K F L M. Remember that K is our dimensionless constant. So always remember to input a K, which is our dimensionless constant. So the next thing is to introduce the powers, which is X, Y, Z. Remember what we did in the first question. So it's just the same process. Introduce the powers, which is X, Y, Z. So we introduce the powers F to the power of X, L to the power of Y, and M to the power of Z. So next thing is to substitute dimensions. Dimensions for V, we have L per T, F we have ML per T square. So just substitute the dimensions into this. Remember, we call this one equation 1. So substitute the dimensions. So now that we've introduced the dimensions, next thing is for us to expand the bracket. So just the same step with the first one we did. So expand the bracket. Now expanding the brackets, we have m to the power of x, l to the power of x, and negative 2 times x will give us negative 2s. So we have negative 2 t to the power of negative 2x, and l we have l to the power of y, and m to the power of z. Now next we have to do is to pick out one base for each of the terms of MLT. You can see here we have 2m and we have 2l, so we'll just pick out one and add the powers. Recall this dot here means multiplication. So in indices, if you are multiplying two bases, you add the powers. So if you are picking out one, we have L per T equals to K dot M to the power of X plus Z dot L to the power of X plus Y, and dot C to the power of negative 2S. So next thing is to equate the powers on the left hand side and that of the right hand side. So here we don't have m. So if we don't have anything for m here, we'll just call it 0. So for m, we have 0 equals to s plus z, because there is no m here, so it equals to s plus z. For L here is 1, and we have L here s plus y, so we have 1 equals s plus y, call it equation 3. Remember, this is equation 2 because we already have our equation 1, which is this. And for t here is negative 1 and t here is negative 2s. So we have t negative 1 equals negative 2s, and we call that equation 4. So next thing is to solve for the values of x, y, and z. Solve for the values of x, y, and z. So if you look at this terms, this one, which of them do you think will be easier to solve? First, here we have two unknown terms, x and y. Here we have two unknown terms, x and z, and here we have just one unknown term, which is x. So you can see that this equation 4 is actually easier to solve. So let's solve for x using equation 4. So from equation 4, we know that negative 1 equals negative 2x, and if you divide by both sides by negative 2, just to make x with the formula, we'll be having x to be equals to 1 over 2. And from equation 3, we know that 1 is equals to s plus y, and we already know that our x is equals to 1 over 2. So we substitute x here with 1 over 2, which is this. So 1 equals 1 over 2 plus y, and that will give us, making y equal to the formula, we have 1 minus 1 over 2 equals y, and our y will be 1 over 2, because 1 minus 1 over 2 is 1 over 2. And from our equation 2, our equation 2 says 0 is equals to s plus z. So 0 equals x plus z. We know that our s is equals to 1 over 2. Substituting it here, we have 0 equals 1 over 2 plus z, which is equals to 0 minus 1 over 2, making z equal to the formula, and we have z equals negative 1 over 2. So now that we know the values of x, y, and z, what's our next step? We recall the formula, the equation 1. Remember what we did last time? We recall equation 1, which is this. So this is our equation 1, which we had here. Now still is to substitute the values of x, y, and z into this equation 1, which are v equals k f to the power of x, which is x is where. So we had our x as 1 over 2, which we substitute here, and we have f to the power of negative to the power of 1 over 2, l to the power of y. We had y as 1 over 2, which we have here, and for m we had m to the power of z, and z is negative 1 over 2, which we have here. So what's our next step? Recall in the first one we did, we are always to the power of 1. So anything to the power of 1 remains that same thing. But here now we have 1 over 2, 1 over 2, and then negative 1 over 2. Now let me tell you something. Anything raised to the power of 1 over 2 is same thing as square root of that thing. Anything raised to the power of 1 over 2 is same thing as square root of that thing. And anything raised to the power of negative 1 over 2 is same thing as 1 over square root of that thing. So as we're having m here to the power of negative 1 over 2, it means 1 over square root of m. And for L here we have square root of L, and for F here we have square root of F. So this is what I mean. V is equals to K square root of F dot square root of L dot 1 over square root of M. And this is same thing as this is same thing as this is same thing as this. Now, are we just going to leave our answer like this? Are we going to leave our answer like this? No. Let's expand or express this equation further. Let's try to reduce to its simplest term. When we have root f or square root of f, multiply this dot here. Remember, I said it means multiplication. Multiply square root of L. We can also rewrite this as square root of f dot L or f multiply L. We can actually put them in one square root. Recall in sorts, we can put this in one square root. So if we actually put this in one square root, we'll be having something like this: v equals k square root of f dot L dot 1 over square root of m. Now let's also express further. We have this. This simply means that k square root of fl is multiplying 1. Is multiplying 1 over square root of m. So remember that anything multiplying 1 is that same thing. So we can actually, rewrite this as k square root of fl all over square root of m. So also recall that this k is a constant. This k is a constant. So if you have square root of f over fl divided by square root of m, we can also write this in one square root. In one square root sign, where we'll be having square root of fl over m. We'll be having this v equals k square root of fl over m. Now let's assume k equals 1. You can leave this as a final answer. This is a final answer, but we assume k equals 1. If we assume k equals 1, we'll be having v equals square root of fl over m, and this is our final answer. Recall, let me go through again. F to the power of 1 over 2 is same thing as square root of f. L to the power of 1 over 2 same thing as square root of L, and m to the power of negative 1 over 2 is same thing as 1 over square root of m. So this in source can also be expressed as square root of f times L, or f dot L, and f times L is what? fl. So we are having v equals k square root of fl dot 1 over square root of m. Now k square root of fl times 1, because this dot here means multiplication, times 1 will give you k square root of fl. That means we'll be having k square root of fl over square root of m. And in sorts also, if you're having square root of fl divided by square root of m, you can express this inside one square root, which will give us k square root of fl over m. And we take what k as 1, assuming k is 1, we'll be having v equals fl over m. Now recall in the question we are given the relationship as this. We are given the relationship as this. Now they are asking what? The question they asked to use dimensional analysis to find the exact relationship. So this is the exact relationship for these given quantities. This is the exact relationship. So if you are solve any question to find maybe the velocity or whatever, you're giving these parameters or you're giving these quantities, this is the formula, correct formula you're supposed to use. So this is the exact relationship for these quantities or for these parameters. So this is how we solve questions under dimensional analysis. And let me give you guys one to do. So just jot down the velocity v for the streamlined flow of a liquid in a small uniform tube depends on the radius r of the tube, the density rho of the tube, and the coefficient of viscosity eta of the liquid. Use the method of dimensional analysis to obtain an expression for the velocity. Also, given that v equals r square p divided by 4 eta L, where P over L equals pressure gradient, obtain an expression for the dimensionless constant in your expression of V. So this is actually easy to solve. This question has two parts. The first part you have to find the dimensional analysis, and the second part they give you an equation which you are supposed to find the expression for dimensionless constant. Remember, I said dimensionless constant is K. So just solve the first part first of all. After solving the first part, where you get your exact relationship, equate what you are given and you'll find the value of the dimensionless constant. So this is all for dimensional analysis.